Hello, everybody. I want to at least talk a little bit about module number 5. And some slides are not really relevant to what we're trying to do here in this summer course. So let's just go from there. So what we're looking at here throughout this entire module are continuous probability functions, meaning that we're essentially trying to calculate areas under a curve in all of these cases. That we're looking at probability distribution functions, and we're calculating areas. And so really the challenge in this module is you being able to determine what kind of distribution it is. If we look at what is a common property of a continuous probability distribution, basically, again, we're talking about a curve. That curve is the called the probability density function, and we're measuring the area under that curve to determine the probability. That's what's being said here. Characteristics. Well, the outcomes are measured, they're not counted, meaning in this case here we're measuring the probability of the outcome occurring. If we added up the area under the curve, it has to equal 1 because everything has to have happened in that time period, meaning that 100% probability for all of the activities. Then, if we look at the if we look at an individual variable, because there is no area under an individual value, we really can't find a probability for it because it's a single point in time. You have to really get it over a time interval. That's what's being said by the third bullet point here. And then for bullet points number 4, 5, and 6, we're just talking about different ways of understanding the area. We don't need to worry about that. Let's start looking at this here. So one way to think about a continuous probability function would be is that if there are 20 different events that could happen, or 20 different numbers that each have a 1/20th probability of occurring. I can't determine any single one because it wouldn't have an area, but eventually you would see here I can calculate here the area of a rectangle, and I would be able to calculate 1/20th. So the area of a rectangle is length times width, so I would do 1/20th times 20 and get 100%. And so then, if I want to know what's the probability of getting from 0 to 2, that would be 1/20th times 2, which is a 10% probability. Not tough so far. Understanding this a little bit of a different way, if we want to understand the interval from 4 to 15, that's a difference of 11. 11 times 1/20th, that gets us a 55% probability. And then what we can do here is we can determine right-hand sides, left-hand side, tails, and the median, and the mean. So now we want to look at 3 different types of continuous probability distribution functions. Let's start with the uniform distribution. So we don't need to remember, again, we don't need to remember how to do the mathematics of this. We've already done some of this already. That would be calculating things like the mean and the standard deviation, which we know that SPSS can do the work for us. Now let's look at the exponential distribution. So in the exponential distribution, well, actually, before we get to that one, I don't even do it. Okay, so let's go back to this here. An exponential distribution is basically the complement to a Poisson distribution, which I'll talk about after I talk about this here. Or actually, I should just talk about it now. In a Poisson distribution, Poisson, in a Poisson distribution, what we're looking at here is the probability to get a number of events occurring in a fixed unit of time, each event being independent. So, sorry, just trying to look for one thing here to help understand it here. Well, you didn't really actually see too many homeworks that were dealing with the Poisson side of this. In the exponential distribution, as opposed to the Poisson distribution, instead of looking at the number of events in a fixed unit of time like you do with the Poisson distribution, what you're doing in the exponential distribution is you're looking at one event happening and then the next event happening, and you're looking at the distribution of time between the events, rather than the Poisson, which is the distribution of events in a fixed unit of time. And so that's what you see here in the exponential distribution. In the exponential distribution, what I'm seeing here is that events are happening, and I want to know how much time happens between them. So we do have examples in the homework that you'll see that use the exponential distribution. That would be something like there's a question where we have the average number of time between accidents. So if you see in the homework that one, that's going to be an exponential distribution. Then we also have the uniform distribution. So in the uniform distribution, going back to this over here, you're going to see this for like 5 questions in the very beginning of the homework. And this is just really dealing with this issue. Let's try to go to this over here. That would be something like this. Now you're going to see what my answer is here, but this is what a uniform distribution looked like. It's called uniform because it's equal probability of each of these events happening over that time period. Going back to the slides. You'll see a lot of math here. Again, I'm not asking you to do it. Here we've got an example here of an exponential distribution, which is pretty useful. But let's actually just, let's be straightforward about this. Let's look at a, let's look at something like this. So here we have a uniform distribution. Now you're seeing here that I got it correct. Let's talk a little bit about how I, in fact, calculated this one. I had 2 minutes of time here, so that's 120 seconds. 0.4, just so you know, I'm rustling papers here because I do each homework question, so I don't want you to think I'm being ever lazy about this class. Even though I'm not... Trying my best here. I'm trying my best. 0.4 is 24 seconds. So that would mean what are the, in a 120 second time interval, which would be from 50 to 52 minutes, what's going to be the average that it's the first 24 seconds out of the 120 seconds. 24 divided by 120 is 20%, which is why I answered this here. For others of these, quite honestly, your best way of doing things are type into the web to look for the calculators. Because really, the most important thing is going to be that you learn in this module when it's an exponential distribution, when is it a Poisson distribution, when is it a uniform distribution. Once you know which one it is, I can type the relevant numbers into the calculator, and that's what I did right here, which turned out to be exactly the answer that I wanted for right here. Interval 3, 7, probability that the sum of the two independent observations of x is greater than 12. Okay. That would mean then that, going back to this, 3 and 7, it's greater than... oh no, sorry, this is not going to reflect that. Sorry, this is actually me solving someone else's. But I would use this interval probability calculator to do exactly that work here. You'll see, so I found this one pretty useful, and you can probably see it, you'll see it in this video, danielsoper.com, StatCalc. I found it to be pretty useful. I found this one pretty useful too, stat.berkeley.edu, sticky GUI, because what's nice about this one is you can actually find the different types of distributions, and you can use that. What's also nice about this is it does do a little bit of explanation for you as well about what these are. So see, I can click on it and I can get an idea of what is a Poisson distribution. Again, I know some of you might really actually want to be doing the mathematics of it, but for summer class, really the best objective here is being presented with a problem, like you are right here, and being able to determine what type of distribution it is. Same here. What type of distribution is it, and how can I solve this? And that's really the point of the statistics within this. Yes, you can do it in a calculator, but actually in this assignment we really don't have anything that needs to be done in SPSS. Really what you want to do when you're solving the questions in this module is identify and bookmark the online calculators that work best for you, and remember what those are, because then when you get to the exam you're going to see the exact same questions, and you just want to be comfortable with how to use that calculator to be able to solve the problem. Okay, that wraps this up.